This conference will now be recorded.
And where are we going in the future? So starting at the beginning, and I'm sure that most of you already know the answer to this question, but what is gauging? And the way that I look at gauging is it's ensuring that there's sufficient space around a moving train for safe operation. And that means trains don't hit the structures, trains don't hit other trains on adjacent lines, or alternatively, it's how big a train can we get through the hole? Or can we increase the speed of the train? Can we have tilting trains while still fitting through the hole? And we have continual challenges. So we are always trying to permit larger or different trains. And one good example of that is the changes in the size of maritime containers for the freight business. So wonderful mix of units here, but this is where they work. The lengths are fairly standard, tend to be 20 foot or 40 foot. The widths are also fairly standard, 2,500 or 2,600 millimeters. And that's because those are the ways that they fit on the ships, who are the maritime containers, obviously. But the heights have increased significantly. The early ones were all 8 foot, 8'6", 9 foot, 9'6". Who knows where it'll go next? And trying to squeeze those through our infrastructure is a challenge. And we get longer passenger vehicles. So we got 20 metre, 23 metre, we've now got 26 metre vehicles. This is all part of the challenge. And I do love this picture, so I just had to put it in. The London Underground example of the challenge of gauging. But let's start with a bit of history. And history is a key part of gauging on the GB system. So if you've got relatively small trains, like some of these historic pictures, and relatively large structures, then you've got lots of clearance. But different railway companies, and our railway was built by a lot of different railway companies, used different structure gauges. And that depended on all the political things you would expect it to depend on at the time. It depended on their funders, it depended on the sponsors. If it was a big prestige project, they probably got lots of space, but some of them didn't have those sorts of funds. And a little bit more history. And both of these images are from Heath Robinson's book, Railway Rivalry. And one thing we did manage to standardise, although the different railways built them differently originally, was the track gauge. So 4 foot 8.5 came in with Britain's Gauge Act. And the wonderful diagrams here are the Great Western Railway being converted in Heath Robinson style from broad gauge to standard gauge, and the obvious union issues that arose. That was the track gauge. Standardising the structure gauge in GB never happened, and it still hasn't happened. We don't have a standard structure gauge in GB. Most of the later railways across the rest of Europe and further afield generally have a larger structure gauge than we do. And that includes the track facing spacing, the 6 foot, as well as other stuff around the railway. They have been learning from our experience. And it's a credit to the imagination of our predecessors that we are still using their network for sizes and types and speeds of trains that they could never have imagined. So what other consequences do we have for this legacy? We've got a lot of curved platforms. There's a picture of one, and there's the analysis that we did for the platform train interface strategy, looking at the curvature of our different platforms. You can decide what you think is straight and what is curved, but for my purposes, I've said that 22% are less than 1,000 metre radius. I think that probably defined as curved. And that inevitably gives us a conflict between getting a straight vehicle onto a curved platform. So we need clearances at the vehicle ends on the outside, on the vehicle centre in the middle, but we need to minimise as far as possible the stepping distances at the range of door positions, which may be at the ends, maybe over the bogies roughly, or with some of the new vehicles, the Elizabeth line, they actually have doors in the middle. Platform height is another challenge for us. We have a target position, which is 915 millimeters height and 730 millimeters offset with tolerances from the track, but most existing platforms are not there, and there is no requirement to modify them. There's no budget for major platform works, and because it's complicated, it's generally deemed out of scope of other station works. Of our existing platforms, and there's about 6,000 platforms on the network, 30% of them are in the target range tolerance for height. That's the pie chart on the left. 22% of them are in the position with tolerances for offset. But when you combine those two, only 7% of our platforms are within the target range for both height and offset. So 93% of them aren't. And this is the average along the platform length. It's not the worst bit of it. This is the average along the platform length. So our platforms are all over the place. And that is a legacy that we have to live with. We also have mixed traffic railways. So we have at most of our platforms suburban trains, regional trains, intercity trains, and freight trains. And we have to fit all of those through. It would be great if we could have lots of clearance, but that's expensive. It's expensive for bridges and for platforms. We don't want to have lots of clearances because then the passengers have trouble getting on and off the trains. So that's why it's tricky. Okay then, so if it's tricky, how do we do it? And that's what I want to go into next. And it's obvious really. If you've got a large clearance, then you can do something fairly straightforward. You can measure the vehicle, you can measure the structure, you can make an allowance, and everything's going to be fine. Most of the time we're not in that position. So we need more complex processes to make best use of restricted space, which means that we have to analyse the vehicle behaviour some way or other. That's usually done statistically. And we very often, certainly in the GB system, we distinguish between the upper sector of the vehicle, which we define as being above 1100 millimetres above rail level, where there's more suspension movement, the vehicle body moves around more, so we need to take account of that movement, and the lower sector, below 1100, where there is less suspension movement, so the allowances can be less. The standard European processes are described in a suite of standards, EN15273, various parts of it, but I must emphasise they are not suitable for application in GB for reasons that I will go to. The GB network, as I've said, is constrained, so we actually have more precise processes and data in order to optimise our use of the system. If we did use the EN system, then we would find that I think probably none of our existing trains would actually apparently fit through the routes that they currently run on. And that wouldn't work very well. So we need more complicated systems. Modern computer techniques help to make that more straightforward, but we still need to be very careful of the assumptions that are written in. So how do we do it? If we look at the standards, then the European TSIs, Technical Specifications for Interoperability, which will be replaced in a no-deal Brexit by the national technical specifications, which are already existing. So they all reference EN15273. But we have specific cases, which are permissions, if you like, to use our national rules. And there's the list of our national rules. And all of these railway group documents are available on the RSSB website, and there's a link to those at the end of the presentation. So you don't need to scribble them all down. Those are the suite of documents that we use for gauging. And in those documents, we recognise a number of different methods. Use of standard vehicle gauges, which I'll come to. Absolute gauging, which is measuring everything. Comparative gauging, which is comparing to an existing vehicle. I'll come back to that as well. Or hybrid gauging, which is a combination of any of the others. There's a very useful document, which is, if somebody wants to look at this in a bit more detail, which is the Vehicle Structures System Interface Committee, the VSSIC, back in 2013 produced a guide to British gauging practice, which is available on Spark. And again, the link to that is on the final slide. And if you use the code name of T926, which is the research project that produced it, you'll find that on Spark if you want to read some more. Just to understand how the EN system works, the principles, they have a range of what they call reference profiles. And on the right-hand side there, you can see diagrams of the different reference profiles. And you will see these referred to in the TSIs and in various other documents. And the important point to notice is that the reference profile is not a shape for the infrastructure, and it's not a shape for the vehicle. It is what it says. It's a reference profile, and you have to go outwards from that to find out where the infrastructure can be, and inwards from that to find out where the vehicle can be, as shown in the schematic at the top left. So reference profiles are an important feature of the EN system. And it's important to note that when it says reference profile GB, that is nothing to do with Great Britain. It's a source of much confusion. So in GB, we don't have reference profiles. We have a number of gauges, and I'll go through some of those, but each gauge has its own rules. And because they've been developed historically over time, they are different for different gauges. They may include assumptions about the lengths and types of vehicles, particularly for the freight gauges. They include quite a lot of assumptions about what combinations of the vehicles and loads are permitted. They may include assumptions about suspension movement. They may allow for suspension movement. They may allow for various other tolerances. And the things that we have for rolling stock, we've got a number of freight gauges. You can see some of those top corners of them up in the top right. And we now have some passenger vehicle gauges, which I'll come back to. But for the infrastructure, we have the lower sector infrastructure gauge, which again I'll come back to. But we have no standard gauge for the upper sector. If we have no definition of gauge for the upper sector. The upper sector gauge in the sectional appendices and in any other documents is defined by what vehicles are allowed to run, approved to run, and at what speeds and with what restrictions. There is no other definition of the upper sector gauge, only defined by what's allowed to run, which is a bit backwards, you might say, for the infrastructure. So what are the methods that we use? We can use comparative gauging, which is, as I said earlier, staying within the shadow of existing rolling stock, but you need to be careful that you've got a sensible comparator, and it needs to be in all conditions, at all locations, at all speeds, and if there are limitations on the comparator vehicle, then those limitations need to be also sensible for the new vehicle. So it's not trivial. Comparative gauging is useful, but it's certainly not trivial. And then there's absolute gauging, which is comparing the swept envelope of the vehicle, which again I'll come back to, with the actual structure gauge. That needs accurate infrastructure measurements, which includes not only the structure, but the track geometry past the structure, because of course that affects where the vehicle might be. And it makes allowances for track movements during the maintenance cycle, measurement accuracy, and so on. And it has to consider a range of speeds. For the outside of the curve, the highest speed is usually the worst, almost always. But for the inside of the curve, it's rather more complicated. And hybrid gauging is a combination of any of the above. So some parts of the route might be covered by one, or some parts of the vehicle and others covered by other methods. That's perfectly satisfactory. And then there are special requirements for equipment that actually needs to contact in order for the railway to work, like wheels and rails, pantographs and overheads, shoe gear and third rail. That's fairly obvious. So the vehicle swept envelope, the vehicle suspension is designed to isolate passengers from the track input in order to give a more comfortable ride. And the suspension movements come from track geometry roughness, which will vary obviously, track layout, curves, cant, transitions, speed, and of course cant efficiency or cant excess on curves. And we also need to account for the overthrow. And there's a very simplistic diagram of centre throw and end throw. And we need to worry about vertical curves as well as horizontal curves. So the size of the vehicle actually depends on where it is, track conditions and so on, and how fast it's going. So the size of the vehicle isn't constant. It's like a swept sausage along the length of the route, and the size of that sausage varies. And in calculating clearance, we also need allowances for track movement, wheel and rail wear, and variation of parameters during the maintenance cycle of the vehicle. So there's a lot of things that have to go in, but we don't want to make too much allowance, or we end up with trains that are rather smaller than they need to be, or holes that are bigger than they need to be, which is also expensive. I'm sure you all know this, but cant allows gravitational force to balance the required acceleration for the curve, but it's only balanced for one speed. So this is my simplistic diagram of the installed cant on a particular curve at a particular speed, perfectly balancing what we wanted. But in practice, if we're going faster, we would like more cant, that's the blue line, but we haven't got it. So there's the cant deficiency, the red bit, the bit we would like but we haven't got. And if we're going slower, then we would have too much cant and cant excess. So cant deficiency tends to make the vehicle lean outwards, unless it's a tilting train, and cant excess makes it lean inwards. And we need to take account of that. So maximum movement to the outside at cant deficiency, maximum movement to the inside is more complicated because the steady state lean will be greatest at slowest speed, but then you've got to add in the dynamics and you've got to trade off. Going a bit faster, you get more dynamics and less lean. What is the worst case? Not trivial. And then we've got, as I said, the gauging trade-off between clearance and stepping distance. And it's important to understand what the requirements really are. This causes a lot of confusion. And for an infrastructure project, whether that's doing something to the track or to the platform, the requirement is the platform position, the height and the offset relative to the track. The stepping distance is, of course, very interesting, but it's not the requirement for an infrastructure project. The step position relative to the standard platform is a requirement for the rolling stock. And as a result of the position of the infrastructure platform and the position of the footstep, then we get a stepping distance. And managing that and the risk arising from it is the responsibility of the train operator and the station operator. And of course, rolling stock changes. We have new fleets coming, we have things being cascaded, and therefore the stepping may also change. It's not fixed. And a comment that I always make, that positive clearance is a requirement, but normal clearances are not. Less than normal clearances may actually be the right answer in a particular location, as long as there is positive clearance. So I would encourage people to always consider use of less than normal clearances if that enables stepping distances to be improved. And always review track fixity. Track fixity is to do with how much allowance is made for the movement of the track during the maintenance cycle. And in station platforms, low track fixity, which is what you use for normal ballasted track in the open, may not be appropriate if it's actually constrained. And then consider what vehicles are actually intended to run. We do occasionally still see routes being gauged for north of London Eurostar, which isn't actually very sensible. We don't really think those are ever going to run. And be prepared to challenge the assumptions. We need to make the best use of our infrastructure, and that means all of us have to apply our technical knowledge and think about whether we're really doing the right thing. So platform positions, and again, you probably know this, the infrastructure TSI gives target platform heights, but they're much lower and we don't use them. So we have our specific case, which is the figures I gave you earlier. 915 millimeters for the height, and generally 730, except on very sharp curves, for the offset. And they're written into our railway group standards, GIRT 7020, or the RIS that goes with it, 7016 for platform height, and the various gauging documents for the offset. For the step, the other side of the equation, as I said, it's relative to the standard platform position and not the actual platform positions on the route. And again, in the TSI, PRM TSI, Persons of Reduced Mobility TSI this time, there's that little shaded blue box, which includes a step down into the train. It doesn't actually include the oversail step, which we permit. And there's the national rule, which in this case is in addition to the TSI as an alternative to the TSI. So that does include the oversail step, but it doesn't include the step down into the train historically. But actually, the whole of that T-shape is permitted anywhere in that red or blue box. And the national rule has been updated, and the specific case is being updated to try and get rid of some of the confusion that having it in two different places has caused. So you will find now the whole of that space in the railway group standard. So that's something about how we do it. So what have we been doing to try and improve it? Because we need to keep improving. New standard gauges, and a lot of this has been driven very helpfully and very successfully by the Vehicle Structures System Interface Committee. They've sponsored a number of research projects to develop new gauges, which I describe as go almost anywhere, because there are some bits of the infrastructure where they don't actually go, but almost anywhere. But we know where they don't. So we know where the exception structures are. And a number of those are now complete and published in the standards. And on the right is a set of diagrams from one of the research projects that developed them. So there's the lower sector vehicle gauge and the lower sector infrastructure gauge, which goes with it, which I'll come back to. And then new passenger gauges, PG1, PG2, and PG3 for different vehicle lengths, 20 metres, 23 metres, and 26 metres, and locomotive gauge. So all of those are now in the standards, and there's work underway, as there always does seem to be, looking for new freight gauges. There are always new challenges on the freight side. The job is never finished. So for the upper sector, talking about infrastructure gauging, how do we determine what's allowed to go? And how do we decide what labels to give the infrastructure in the upper sector? So if a structure is clear, i.e. it has a suitable clearance of the dynamic gauge for a standard freight gauge or standard vehicle gauge, and it complies with the overthrows, then it can be defined as cleared for that gauge. So the vast majority of the GB network is cleared for W6A gauge. Bits of it will be cleared for W10 or various other freight gauges, and most of it is cleared for PG1, PG2. When I say the required clearance, that doesn't mean normal clearance. They might be normal, they might be reduced, or they might be special reduced, and there are numbers associated with all of those in the standards. And as you would expect, when the clearances are smaller, then there are more stringent inspection and maintenance controls because we're more worried about the track movement and various other things. If a structure isn't cleared for a gauge, so the structure doesn't apparently fit PG2 passenger gauge, that doesn't mean that a particular vehicle that's compatible with PG2 won't fit, because absolute gauging might actually demonstrate that along that particular route, the conditions under which the incompatibility occurs don't actually exist. But that's obviously a bigger piece of work than just checking against the gauge, though checking against the gauge is not trivial either. So that's for the upper sector. The lower sector is a bit easier. So for the lower sector, we've actually documented in GIRT 7073 the lower sector infrastructure gauge. And this is now really an infrastructure gauge, so it includes all the bits of the infrastructure. And all new infrastructure must comply with it. And most existing infrastructure complies with it, and we know where it doesn't. So there's the general picture, which is that one, but then there's a lot of specifics, and I'm not going to go through the details on this slide. It's just there to show you that it's there, it exists. It's all in GIRT 7073, but it includes things like third rails, fourth rails, trip cocks, all the sorts of other stuff that is essential on different bits of the railway to have around the rail level. So where it can be is all defined in 7073. And measuring things. The National Gauging Database contains structure profiles for the whole, more or less, of the infrastructure of the network. It's a live database and it's continually being updated. And as I said earlier, the accuracy of the measurement is most important where the clearance is tight. If there's lots of space, then we don't need to worry so much about the accuracy of the measurements. And as I alluded to be useful for gauging, any measurements, whether they're of a tunnel, a bridge, the girders of an underbridge, platforms, need to include the relevant site details. So track, curvature, cant, geometry, and relative positions of adjacent tracks. The structure measurement without the track measurement is actually no use for gauging at all. And a measurement of the platform relative to the track also needs to know what the track's like. Gauging uses the concept of the maintained position of the track as the reference. Ideally, that would be a design position, and the track is returned to a design alignment during maintenance. That's not always the case. Sometimes the maintained position isn't documented and the actual position has to be used. But the concept is the maintained position, not where it happens to be on the day. So a few other things to think about for gauging. Different people are responsible for different tolerances. So the infrastructure manager is very reasonably responsible for the track alignment, the rail side wear, head wear, all of those things, and of course the track quality, which will also affect the vehicle swept envelope. Clearances, as I said, can be normal reduced or special reduced with appropriate controls, and positive clearances are required, normal clearances not always. And to come back to track fixity, you all know, and it's the name of the institution, that the permanent way is certainly not permanent. And conventional ballasted track is considered low fixity with related allowances for movement added into the vehicle envelopes. Things like glued ballast, track that is strutted away from a solid platform face are considered medium fixity and with different tolerances, and slab track is actually considered high fixity, fairly obviously. And Network Rail have a research project about to get going, looking at track fixity in a lot more detail and seeing if they can use the measurements of the track geometry to understand what the fixity of a particular location really is. And that will be very exciting to get much better data on how much allowance we really need for track fixity. So, what are the requirements on the infrastructure? It's not permanent, but the infrastructure is a very long life asset. So we really do want to future-proof it where possible. And in GIRT 7073, there are clear requirements for new infrastructure, and we'll come back to that, and for modifications to existing infrastructure, where the objective, I think fairly simply, is don't make it any worse. If we're doing something to the existing infrastructure, at least maintain what it can do at the moment, and if possible, improve it. But it does explicitly say that if a project is to permit the passage of larger vehicles, that might be freight, that might be passenger, then normal clearances are not mandatory if the appropriate controls are implemented. And that can make a big difference if it means we don't have to rebuild a bridge. If we can actually get through the existing bridge with a bigger vehicle without rebuilding it by using smaller clearances, that's probably the best economic balance, but it needs to be looked at. And temporary infrastructure can actually be more of a risk than permanent infrastructure because we don't worry about it so much, but we should. It needs to meet the same requirements as new infrastructure, and it does require very careful design. And station platforms, I could talk for hours on station platforms, but I'm not going to today. It's all in the other documents. And electrical clearances are also in other documents. I'm not going to talk about those today. So if we talk about new infrastructure, let's take the upper sector. If it's new infrastructure on the new line, we don't do a lot of that, but we do some. Then we need to accommodate all of these things. Overhead line equipment, normal clearances to all standard vehicle gauges, and normal clearances to all types of rolling stock, which the infrastructure manager can reasonably foresee using the route. It's a judgment. And access for staff, so that's line side walkways, access routes, and so on. If we've got new infrastructure on an existing railway, then we need to be realistic. We must accommodate the passive provision at least for overhead line equipment, and at least normal clearances to all types of rolling stock that actually use the route or which have a statement of compatibility for the route. And don't forget what's euphemistically called the window box, which is the box that we need where vehicles operate with opening windows that people might stick their heads out of. And that applies whether those windows are used by passengers or only by staff. There is still a requirement for additional clearance at the window box level, even if the windows are only available for staff. And there's guidance in the guidance document on clearances. Overhead line, as I said, is in other documents. For the lower sector, I think I've touched on most of this already. Stick with the lower sector infrastructure gauge, and the same applies to new track. Don't position new track so that adjacent infrastructure would be not outside LSIG. And make allowance for construction tolerances. The platform position we've talked about, and 7073, as I've said, includes requirements for conductor rails and guard boarding and all these other things that are required around the railway. And the track intervals, the so-called 6 foot, which in most cases is not 6 foot, has to take into account those requirements for normal clearances, including the window box, and adequate space for all the other trackside stuff that we do still need. We haven't yet got rid of all of our trackside furniture. So, my fourth section is a little bit more of a forward look. And strategy is a wonderful thing. And the nearest we have to a current strategy for gauging on our network is in the Scottish HLOS, the High Level Output Specification for CP6. I've given a couple of extracts from it here, but it's actually a very interesting document and it's not very long, so it's worth Googling it, finding it and having a read. So for Scotland, the Scottish ministers have said what they want for the gauge of the Scottish bit of our network for CP6, and there it is. We don't have the same for England or Wales. The VSSIC is putting together a gauging strategy. They've developed a document which they call a vision for the Great Britain Railway Network, but it's not funded and it's not at the moment got a route to funding. So to give that a bit more detail, they've developed it. This is a long-term strategy where they're setting out a vision of where we would like to get. So what is the size of the infrastructure? What is the size of the vehicles? Not all the same. Different bits of the network may be different. What are the interface considerations? And what research is required to actually get us there? And they've identified some aims, which is maximize capacity, however you determine that, increase the use of standard infrastructure and standard rolling stock gauges, make the processes less complicated, less time consuming, less expensive, and hopefully also reduce the costs of assessment, inspection and maintenance. And at the same time, improve the customer experience with things like the platform train interface. But the funding, and it's a big but, there is no funding currently to deliver the strategy. And there's an existing research project which is looking at how it might be possible to develop a business case to see if we can make this strategy a reality. It's not easy. But if we don't know where we want to get, it's very difficult to know that we're going to get there. I said I wasn't going to talk at length about platforms, but I am going to mention them. So I've told you what our current platform target position is. Most of our trains, not all of them now, most of our train floors on the mainline network are higher. So there's generally a vertical step at the PTI, and there may also be a horizontal gap. And what can we do about it? It makes it harder for people to get on and off. It slows things down. It affects performance. So in developing the platform train interface strategy, we looked at platform height and we looked at vehicle footsteps. And generally, and I'll come back to this, the vehicle footsteps are constrained to go anywhere because that's what the vehicle funders want. They want a train that is completely flexible. It can go in any part of the network without any modification. You can understand why they would want that. So a question we often get asked is, our footsteps are higher than the platforms, so why don't we just raise the platforms? And this is the conclusion that we came to. The black one at the bottom is the current target position. And then we looked at various different heights, going up from 915 to 1115. And what we've got there are the offsets that you would need to build the platform to. And this is not on the sharpest curve. This is on a reasonable spread of platforms. And it's not with normal clearances, it's with reduced clearances to standard vehicles, W6A, upper sector and lower sector. So if we raise the height, then we end up with a bigger gap. And the risk assessment doesn't suggest that that's a good thing. So we conclude that 915 is still the right target height. There are some specific locations which have higher platforms or higher sections, but they're associated with constraints on what vehicles and in what conditions and so on. So what about lower floors? Well, there are two new fleets, one introduced, one coming, with lower floors. On Greater Anglia, that's a photo that I took at the end of last year. That's one of the new low floor trains on Greater Anglia. The Merseyrail vehicles are coming to be introduced later this year. The first ones are now on test. And both of them, and this is also a photo from Greater Anglia, also include an automatically deployed stepping plate, which has a platform sensor so that it knows when to come out and how far to come. And I took that photo at Great Yarmouth, and that's the curvy end of the platform at Great Yarmouth, and that's the footstep out as far as it will go, but the remaining gap is pretty small. I couldn't even get my foot down it. So it really does help to fill that gap. And some locations will now be a step down into the train where the platform is higher. That's new for GB mainline passengers, but it's very familiar on other networks. People do it on London Underground a lot of the time, and networks across other railways are very used to stepping down into trains, so it shouldn't be a problem. Merseyrail have also undertaken platform and track work to bring their platforms to the standard position, which is why they are able to fit those extra bits along the vehicle body that you can see in the schematic at the bottom right, which fill the body side gap away from the platforms, which is another area of risk. They couldn't do that if they hadn't reduced the height of some of their high platforms. So high platforms, those are the red ones in the front. They're high and they're close to the track. And they're the ones that are actually constraining our vehicle footsteps. The little smiley in the middle is the 7% of platforms that conform to the current target positions. So we decided to have another look at high and tight platforms. And research project T1166 updated the recent National Gauging Database platform data, cleaned it up, had a good look at it, and statistically decided on various definitions of high and tight, looked at their locations, and the high and tight platforms are not concentrated in one particular bit of the network. They do exist in quite a lot of locations, as you can see from the map on the right. And then in the second part of the project, we used delay data from Cross Country's franchise to look at the influence of the step and gap dimensions on platform dwell times. We've tried in the past to see if we could use safety data, but the safety data, unfortunately, well, fortunately perhaps, there are not that many incidents, so the safety data isn't very rich. The delay data is much richer, and they've built the bones of a business case that demonstrates that there is a business case potentially for progressive modifications to the platform or the track to reduce particularly the vertical stepping distances. And the final reports on that, T1166, are also now available on Spark if anybody wants to have a look. So a little bit about where we're going next on high-speed trains. And again, I'm sure many of you know this, the original Eurostar trains, the 373s, were designed to fit on parts of the UK mainline network. So they were smaller. The new Eurostars, 374s, are built to standard European gauge and can only run on HS1. And they're both designed for low platforms, not our classic 915. The high-speed 1 route is cleared according to the EN15273 to GB1 and GC on different sections. And as I said before, GB is nothing to do with Great Britain. And I did my best to take some pictures of the two different Eurostars. It's actually very difficult to see the difference in size. The lower pictures are perhaps clearer, where you can see that if you look at the front, the height looks pretty similar, though the new one on the left is slightly higher, but then it goes up again much more. So the 373 on the right is actually significantly smaller than the 374 on the left. So what about HS2? HS2 is planned to be built to GC gauge, except for the platforms. They propose to use higher platforms to match the floor height of high-speed trains. And they will have two separate vehicle fleets, the dedicated high-speed trains, and certainly in the earlier years, classic compatible trains that also run on the classic network. And those will obviously have to be built to a gauge compatible with the UK historic network, and so they will be smaller. And that is going to give a challenge for the platform train interface, because the classic compatible trains will need to stop at both the high platforms and the existing 915 platforms. So that's a quick scoot through a number of things, and I said that there were links on the end, and there you are, to the various RSSB documents on rssb.co.uk and the research reports which are on sparkrail.org. That's it from me.
Thank you very much, Bridget. Can everybody hear me? Can anybody hear me?
Yes,
we can.
Thank you. Good. Right. Thank you very much, Bridget. That was excellent. Nice to see that the Scots are ahead of the game again. And it's a shame that we still seem to be designing. We still seem to be providing clearance for trains that will never run on those particular sections of the network. Right. In terms of questions, I've got 3 questions. First one, Peter Halliwell's asking, do all the national rules numbers end in 73 by design because the EN ends in 73 as well?
Yes, is the simple answer to that. We wanted to try and find a suite of numbers that people might have stand a chance of remembering, and having them all end in 73 was the easiest.
Excellent. Thank you, Bridget. Another question from Peter. how do PG1/PG2/PG3 relate to W6A gauge?
That's a difficult question. The lower sector is fairly similar. So the space for the bogies and things. There's some wonderful background noise. The rules of the gauge are very different because passenger vehicles have much more suspension clearance to make life comfortable for the passengers. So the suspension is more flexible and the body moves about. So it's very difficult to compare the shape of a freight vehicle with a fairly stiff suspension to the shape of a passenger vehicle with a much more flexible one. And particularly for the PG3, of course, they're also longer. The bogie spacing is longer. So W6A is probably the smallest. If you can just get W6A freight vehicles and track maintenance vehicles through, then in certain circumstances, none of PG1, 2 or 3 would fit. If that answers the question.
Thank you, Bridget. I'm assuming that does answer the question.
Peter says yes, thanks in the talk. So chat. So presumably that was
yes, just got that. Brilliant. Thank you, Peter. Thank you, Bridget. Graham Clark is asking the question: given that large parts of the network have been cleared for 9'6" containers, what scope is there for larger passenger stock to exploit that area? Could we fit double-deck vehicles in?
I'll take the second half of that question first. And interestingly, the problem in fitting double-deck vehicles is not up the top end. The problem with fitting double-deck vehicles is our platforms. So if you work out what the space between the platforms is, you can't actually get enough people sitting in the lower deck to make it worth having. Because with a double-deck vehicle, you don't just go up, you have to go down. So the lower deck is lower and the upper deck is higher. So it's actually the lower end that's the problem in getting double-deck vehicles in. So yes, you could get bigger vehicles in up the top, but again, you have to remember that passenger vehicles sway more. So you would end up with something which probably tapered in even more at the higher level than the tilting trains do. And some people find even those quite claustrophobic because of the way that they come in at the top. There was the first part to that question as well, wasn't there? I've forgotten it.
Sorry, yeah. Given that large parts now have been cleared for 9'6" containers, what scope is there for larger passenger stock to exploit that area?
Yes, so in principle, it could. I think I've answered that one.
Yeah, absolutely. All right, okay. Had another couple of questions come in during the question session. David Woods says, hello, Bridget. Do you have any thoughts on probabilistic gauging?
Essentially, what we do at the moment is, in a fairly simple way, probabilistic, because we don't take into account all the possible worst combinations. Otherwise, no, we wouldn't do anything. So we don't take the worst possible suspension movement, we don't take the worst possible wheel wear, we don't take the worst possible rail wear all at once at the same place. So it is probabilistic. And with more modern computer techniques, various people are looking at the possibilities of being perhaps a little more rigorous about some of those probabilities and how we combine the different combinations. So by all means, it's a very sensible thing to look at. Clearly, we want confidence, a sensible confidence level in what we come up with, but we are certainly not looking at the combination of all the worst possible cases.
Excellent. Thank you, Bridget. 2 more questions coming in. Okay. Question from Piers Connor, or Connor Piers. Would a train with a single... Yeah. Would a train with a single failed extending step have to be removed from service?
The answer is yes, unless the step could be physically pushed back in and the door locked out of use. You couldn't run it with the step stuck out. But those types of vehicles and those steps have been in regular use across large numbers of other European networks for decades, and they don't seem to have caused a problem. So we have no reason to believe that they're going to be a cause of unreliability. And equally, I'm not aware of, and we've had extending, folding down steps on the Pendolinos ever since they've been introduced on the West Coast. I'm not aware of those causing significant reliability problems. So yes, of course, Piers, you're right. You would have to take it out of service if you couldn't make sure that it was in, but I don't think it's a problem.
Okay, thanks, Bridget. Next question, Sharad Mahmood says, is there an option of using ramps in trains for easier access instead of steps where possible?
That's a good question. Anything's possible. You need to design it into the train. And I assume that he's not talking about the deployable ramps that require staff to fit them. There are ramps on some other continental trains that come out and then lower themselves onto the platform, but they tend to be a bit slow compared to a step which comes out fairly rapidly and doesn't put too big a change on the dwell time. So it's certainly possible. I suspect that there are good reasons why most people don't do it.
Okay. I think it's probably quite a bit of gradient potentially on there that might prevent them from being safe or usable.
That's another good point. I mean, the deployable ramps are quite long in order for the gradients to be manageable by a wheelchair. Yes.
Okay, thank you, Bridget. Last question, and just a note from Felix, noting that the Class 373 also has deployable steps.
Indeed, it does. Yep, they've been in use for some time.
Okay, and the last question from Peter Halliwell. Vehicle gauges usually are presented as a cross-sectional profile. How is tapering at the vehicle ends included in the swept envelope provisions?
You'll find if you look at take PG3 as the most extreme example because it's the longest. It includes more than one cross-sectional profile, so it recognises that the vehicle ends do taper. So that is included in the definition of the gauge that's included in the spreadsheets, and it can taper by any arrangement that people want. The standard gauge is PG3, for example, has I think only two cross sections, but you could have more, and then the swept envelope takes that into account.
Excellent. Thank you, Bridget. And that can. Oh, hang on a minute. We've got two more questions. Would it potentially be cheap? This is Jacob Fay. Would it potentially be cheaper to alter platforms rather than design tamping?
That's a very interesting question, and the people who are best able to answer that are actually Merseyrail, because in adjusting their platforms for their new trains as part of a whole system approach, they've actually been through the discussions with their Network Rail colleagues for that, and they've got 90-something platforms. It's not a small number, and most of that is now done. As to whether it's easiest to modify and cost-effective to modify the platform or to modify the track to get the platform relative to the track where you want it to be, and it's not a simple answer. It depends on the case. Now, some cases you can't adjust the track because you've got no level crossings over bridges or underpasses, whatever that constrain where the track has to be, and in some cases, if it's a listed building, it's very difficult to modify the platform. So it's a trade-off. But yes, both of those things are sensible things to do.
Fabulous. Okay, last question. Well, let me see. Actually, state it's obviously sort of a query rather than a question. Alexander Baldwin has mentioned, are you aware if the new passengers? No, this is a question. Are you aware if the new passenger standard gauge has been developed with consideration for the reverse curve criteria that's defined in EN15273?
It's been designed for probably worse than that, because it's been designed for the existing network. There are exception locations, but they fit the vast majority of the existing network, and I'm pretty sure there are some locations on the network that are worse than, certainly worse than the TSI requirements, which I think call up that EN, though I'm not very good at remembering all the EN numbers. But it's certainly been designed for worse reverse curves than we would now install.
Okay. Thank you, Bridget. I think that concludes the questions. There's some notes that have been submitted just for information. Graham Clark, it is worth noting that the Merseyrail approach was prompted by the RAID report on the James Street accident.
Yep, that's correct. Thank you, Graham.
Okay. And a note from Giselle, the applicability of the clearance requirements to structures at window level, also known as window box, is likely to change from new infrastructure to new and altered infrastructure.
Right. Thank you, Jess.
And that I think that's the end of the messages. Thank you very much, everybody, for the messages and for participating. And thank you, of course, Bridget, again for stepping in at short notice, providing an excellent presentation. It just leaves me now to hand over to Dermot Kelly for the vote of thanks, and he's kindly volunteered to do that. Thank you. Over to you, Dermot.
Okay, how we do a vote of thanks like this will be a new experience for me.
Yeah, I think we need to unmute everybody so that we can hear the vote of thanks. Yeah.
Bridget, that was a great presentation as always. Thank you very much. A couple of fascinating things that came out of it for me was the fact that we've never had a standard for structure gauge, although we managed fairly early on to get a legislation for a standard gauge, and I suppose it's quite worrying that only 7% of our platforms are within standard, and then the standards themselves I think must be a nightmare for the uninitiated, and you can well understand, given the things like absolute, comparative and hybrid gauging, why it's regarded as a bit of a black art. And I wonder, do we miss, through all that complexity, we miss some obvious benefits such as sorting track fixity out and being overly conservative. But I think the thing that really jumped out for me was the fact that we have been without a strategy probably has led to a lot more complexity in the whole area of gauging than there needs to be. And I think that's maybe something we can all reflect on in the future. So with no further ado, if everybody could applaud in the traditional way, we'll see what it sounds like. Thank you very much, Bridget. Thank you.
I think that worked. Thank you.
Excellent. Thank you very much, everybody. And the only thing to say now is see you again, or listen to you again, or for the William Powery on May the 21st. And just remember that the start time is going to be 1 o'clock in the afternoon rather than the conventional evening meetings. Thank you very much, all.
Thank you, Bridget.